Hello. Yes, we welcome you back to PSSB with me, Richard here. The question comes, define dative or coordinate bond. What is it? Okay, this is the type of covalent bond in which both shared electrons are contributed by one atom, the donor. Yeah, that is that. Yeah, before I go to the next question, I need to emphasize here that if you have been taking note that in all the covalent bond we have discussed so far, the shared pair of electron was contributed by both bonding partner, one atom contributing one and the other one contributing the other. That is not the case with dative bond. In dative bond, both the shared electrons come from one atom, which we call the donor, going to the other atom, which we call the receiver. Okay, then we come to this question. It says, describe the formation of covalent coordinate bond in each of the following cases. The first one is formation of ammonium ion from ammonia. Okay. For the information's sake, I need to tell you that what you call ammonia is NH3. And this one tends to react with hydrogen ions to give you NH4 ion. Now, this reaction involves coordinate bonding. The hydrogen ion is attached to ammonia by coordinate bond. Let us analyze it and we see what happens actually. If we recall our ammonia, the central atom is nitrogen, and the nitrogen has 5 valence electrons, which we distribute as 1, 2, 3, 4. Remember now there are 5, so pairing starts. Okay. Now, when you analyze this one shows you that nitrogen has the capacity to form 3 bonds. You have to recall that it is only unpaired electrons which can bond. So, hydrogen comes there, bringing its electron. Another one comes here, bringing its electron. Another one comes here, bringing its electron. So, what you have here is the ammonia. And now ammonia is bonding with hydrogen ion. Now, I need to tell you that hydrogen ion, unlike a normal hydrogen atom, hydrogen ion does not have any electron. By indicating it positive, it implies that it lost its electron. When a species loses electron, it becomes positive. So, in other words, this hydrogen ion we have here does not have an electron. So, what is going to happen here is that these 2 electrons, or these 2 paired electrons, which we call a lone pair, is the one which is going to be used to bond with hydrogen, giving us that one, nitrogen, with our bonds. What are the bonds here? Remember this side we have hydrogen atom, and this one will have hydrogen atom, and this one will have hydrogen atom. 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 And this one will have Then our lone pair here is the one which is holding that hydrogen ion which came. And the coming of this positive makes the entire unit to be positive. Now, as you can see, this is a normal covalent bond caused by donations from both atoms. This is a normal covalent bond caused by donation from nitrogen and hydrogen. The same applies to this one. But this one is what we call the dative bond. It is different because both the shared electrons were donated by nitrogen. So under the circumstance, nitrogen is the donor and the hydrogen is the recipient. So that is the case. Yes. Then comes this question. It says, describe the formation of covalent coordinate bond in the formation of hydronium ion from water. This is what I need you to know, that this is the case. You have water, and if a proton or hydrogen ion comes, this is what is going to happen. It will bond to that water, giving you hydrogen ion, this one. And the formation of this species involves coordinate bonding or dative bonding. So let us analyze what we know. For water, the central atom is oxygen, and oxygen is a group 6. So, meaning that you have 1, you have 2, you have 3, you have 4, then 5, and 6. So when you look at this oxygen, what does it mean? It means that it has the capacity to make 2 bonds. Okay? Because bonding occurs between unpaired electrons. So what are we going to have here? We are going to have that one and that one showing bonding with hydrogen. Okay. So that's what we have. So technically, this is the Lewis structure for water molecule. Okay. Then we proceed that if a hydrogen ion comes, like I said before, a hydrogen ion does not have any electron. It lost it. That's why it's positive. That's why some people call it a proton, because remember, a hydrogen has 1 electron and 1 proton. So after loss of an electron, what remains behind is a proton. So don't blame people when they call hydrogen ion a proton. But that's not the case. The case here is that this one is going to bond with this one. How is it going to happen? This is what is going to happen, that one of these 2 lone pair is going to be the one bonding with that hydrogen ion. If that one occurs, this is what is going to happen. Okay. So we go back to our structure of oxygen. Remember, our oxygen is known, and we know that at one time we have that bond and that bond. Bonding with what? Bonding with the hydrogen. Okay. But now the two lone pairs are also there, but one has been used to bond with the hydrogen ion. And because hydrogen ion was positive, that one makes the entire species, this one, to be positive. So what you have here is the Lewis diagram for hydronium ion. Also not forget that this shared electron here is what we call dative bond or coordinate bond. Because both shared electrons were contributed by oxygen, this is a normal covalent bond where both partners contributed to it. The same applies to this one. This one is a special one because both shared electrons were contributed by oxygen. So oxygen is the donor and hydrogen is the recipient. And with that, I would like to thank you for your time. The channel is PSSB Physical Sciences Silver Bullet with me, Richard here. Yes, we urge you to subscribe, to comment, to like, to share. And we also advise you that if you are using the channel, please use the playlist. Don't go to video. This channel has a very wide scope. So we have arranged the material for you in the playlist. Grade 8 and 9, just look for Natural Sciences Grade 8 or Natural Sciences Grade 9. For Grade 11 and 10, on Physical Sciences Grade 11 or Physical Sciences Grade 10. For Grade 12, I need to tell you that each topic is presented independently. So each topic is a tile. Just click on it and you'll have all the material which belongs to that topic. With that, I would like to say thank you. Bye-bye. See you next time.